Welcome back to another lecture. This is lecture 4, and today we're going to be moving on to the next module, which is integers. So first, let's talk about what an integer is. We're mainly just going to get kind of comfortable with them in this lecture. So you may recall, but we'll go ahead and go over it now, that numbers can be written on a line. And imagine this line going off infinitely far in each direction, and at some point on this line, you have kind of the defining point being 0. The concept of 0 has been around for a long time, but historically it was developed quite a bit later than, like positive numbers, for example. 0 is kind of foundational in what we're going to be studying with integers, and it has a defining property for the integers, and we'll talk about that as we go along. And over here to the right, which again extends out to positive infinity, and just to note, infinity is not a number, so it's kind of off the number line. It's just saying in the direction of infinity. It goes on forever. We have 1, we have 2, and like I said, it keeps going. And then on the left side of 0, we have 1 unit in the negative direction. So -1. If you will, it's like if you had an arrow going from 0 to 1, it is the opposite. It is the opposite of that. Instead of going from 0 to 1, going to the right 1 unit, we're going to go to the left 1 unit. So that's -1. We also have -2. So instead of going to the right 2 units, we're going to the left 2 units. And in general, we can kind of explore whether things are on the left or right. That is well defined in the integers. So, for example, on this number line, 2 is to the right of -1. So the way we do that, we can kind of say 2, right arrow, -1. So 2 is to the right of -1. And we can drop this line and just say 2 is to the right of -1. Now, another way to remember this is something that I think we may have all at least heard about before, but if not, whenever you're trying to figure out which way does the sun go, we can imagine it as being an alligator with teeth and saying the alligator always eats the bigger number, right? The open side is always toward the bigger number. So for example, if we had the order of these reversed and we were trying to figure out which one's to the right of, which one's to the left of, well, 2 is to the right of -1, and so we would write it like this, or you could say alligator always eats the bigger number. The open side always goes toward the bigger number, so this open side's going toward the 2. But the way I like to remember it is kind of the arrow, as -1 is to the left of 2. And you can see up here -1 to the left of 2. So that goes over greater than, less than. There is another slight alteration to this notation, and that is greater than or equal to. And that means just what it sounds like it means. So for example here, this says that 2 is greater than -1 or 2 is equal to -1. So just one of these has to be true. And in this case, this is the one that's true. But whereas 2 is not greater than 2, this is not true. 2 is greater than or equal to 2, right? It kind of satisfies that second case of them being equal. So just want to note that. A couple more things to talk about to kind of get this introduction to integers down is what it means for something to be the opposite of or the inverse of. So on that number line, like I mentioned, and we'll actually go back a page, 2 is 2 units to the right, -2 is 2 units to the left, right? And so the way to kind of think about -2, or the conventional way of thinking about it, is that -2 is kind of the opposite of 2. So let's take a number and do the opposite of that number. 2, we said the opposite's -2. 5, The opposite is negative 5. In the same way, we can talk about the opposite of negative numbers. So going back to our number line here, the opposite of negative 2, well, negative 2 is 2 units in the left direction. So the opposite of that would be 2 units in the right direction, which is positive 2. So the opposite of negative 2 is positive 2. And you can see that this operation is this opposite operation is what we would call symmetric. So if we have any number, just think of your favorite number. I'll call it n. And the opposite is negative n. Then the opposite of negative n is going to be n, if that makes sense. It doesn't matter which way you order it. The opposite of n is negative n. The opposite of negative n is n. And I think this is probably a difficult concept well, this particularly I don't think is a difficult concept, but a lot of times whenever you see something like what we're about to go over, it can lead to a little bit of confusion. And that is the way we do this opposite operation is through the minus sign. So for example, the opposite of 2 is negative 2, so we put the minus sign there. The opposite of 5 is negative 5, so we put the minus sign there. Now, you may be asking, what about this negative 2? We actually dropped the minus sign, and that is true. But the actual thing that we did, whenever you look at the operation, is the opposite of negative 2, which in another way of saying it is the opposite of 2. So those opposite of, it's like, you know, running from point A to point B and then going from point B to point A. They kind of cancel each other out. So the opposite of a negative number, let's say negative n, is going to be n, just like we talked about up here, which I think probably makes sense, right? We went n units to the left, and now we're to kind of undo that, or to talk about the inverse of it or the opposite of it, we're going to go n units to the right. But what may get confusing sometimes is whenever we say that, what we're actually doing is negative n, or the opposite of n. I don't know why I'm doing an arrow here. There should be an equals n. So hopefully that clears that up. There's one more thing I want to talk about, and that is absolute values. So I'm going to go ahead and draw a number line up here again. 0, 1, 2, -1, -2. And there's something to be said about, you know, we have 2 units to the right is 2. 2 units to the left is -2. Either way, either -2 or 2, it's 2 units away from 0. So if we're just measuring this as the distance away from 0, 2 is 2 units away from 0. -2 is 2 units away from 0. So the operation we're actually doing here is called the absolute value. And for any positive number like 2, the absolute value is just that number. And the way we write that is with these bars around the number. We're saying how far is this number away from 0. But we also said that -2 is the same distance as 2 away from 0, namely it's 2 from 0. 2 units to the left, whereas this is the regular 2 is 2 units to the right, this is 2 units to the left, but both of them are 2 units away from 0, so they have the same absolute value. So in general, and you're not expected to memorize this particular notation, I just want you to see it. If we have the absolute value of a number n, it will be just n whenever n is positive or 0. So n is greater than or equal to 0. N is to the right of or equal to 0. So in particular, this 1, 2. The absolute value of things over here is just going to be n, whereas the absolute value of -1, -2 of things over here, well, -1 is 1 away from 0. -2 is 2 away from 0. So we're doing, if we go back to that opposite notation, notice that we're taking the opposite of -1, the opposite of -2, and if we had -3, we'd take the opposite of -3. And so the way we said we would write that is the opposite of -1, the opposite of -2, the opposite of -3. And so if this in the middle here is our number, n, then we're saying negative n, negative n, negative n. So whenever n is less than 0, or n is to the left of 0, we're going to do negative n. And this is actually how the absolute value is defined. Okay, that is all we're going to talk about for this lecture. We're going to, in the next lecture, start exploring some of the properties of numbers being to the left of 0, numbers being to the right to 0, otherwise negative and positive numbers, which together with 0 form what are called the integers. All right, see you in the next.